guys, that's an FPGA PCB right there. As you can see, it has an FPGA chip here on the middle, some IOs. So what we're gonna do today is try to put ourselves in the skin of someone that's gonna discover this field and do some beginner's project. All right, to see like how hard can it be. First of all, let's try to power on the board. Alright, LED is already blinking. This is because I put like a CPU, the holy core on there. That's another video that I made. It's kind of complicated. Today we'll rather focus on this. I think you are more familiar with this. This is a breadboard with like a resistor and a couple of LEDs. Today we're gonna try to kind of use this board that looks like an Arduino with all the IO shields, etc. and try to do some Arduino-like project for beginners, except this is not an Arduino. And this is something that's pure hardware logic right there. The tools are not the same, the workflow is not the same, the code is not the same. Alright, so just like an Arduino, this board has some pins exposed to 5 volt and ground. If you don't have this specific board, of course, you will still have some pins exposed to 5 volt and ground. Like every board has that, pretty much. Alright, you can see the yellow one is like really hard to see. It's like not working at all. So let's keep the red one. This LED has seen better days, but like this is just putting power through an LED. It's like pretty useless. What I suggest is like we try to actually blink it using the board's IOs. Okay, so what are we even going to do right now? Because right now we are dealing with pure hardware logic, which is kind of confusing when you're just starting out. In digital circuits, you have what we call clock. And the idea with a clock is that it runs at a certain frequency, and we can use that to do stuff, including increasing a counter, for example. And once this counter arrives at a certain value, what we're going to do is that we'll assign 1 to the LED, which will just turn it on. And once this counter overflows, well, we'll turn the LED to 0. And because the counter overflows, well, it will naturally start back to 0, and this will cycle through on and off and on and off for the LED, which will blink it. This is a Xilinx FPGA. Depending on your FPGA manufacturer, you will have to use a different set of tools. So we want to launch Vivado. I'm on Linux, so I have to use a terminal to launch it. Okay, so I already laid out an LED blinker. There you go. It's like extremely simple. Of course, we output an LED state. What we do is that we increase the counter on every positive edge of the clock. And the idea is we use 25 bits because 2 to the power 25 is kind of close to 25 megahertz. We assign the 25th bit to the state, and that's it. I made a little block design as well. So Vivado is nice enough to recognize my board and to set up the reset and sys clock automatically. So we have a 25 megahertz clock here. Going into the LED. Here the LED state is going nowhere. IO 0. Control F this shit. Okay, it's right there. So it's L13. So we're gonna take L13 and put it right there. So now what we want to do is generate a bit stream. The right bit stream is already complete. Open the target. Auto connect. It should recognize it. Alright, it did. I'm going to program it. Boom. Theoretically, the pin that I use is this one right over there. Alright. So let's try it out. Oh, it's working actually. It's actually working as well. Okay, so that was a pretty good project overall. It's really meant for beginners. I think the only difficulty here is like to understand the tools, and let's move on to the next project. So I also have this thing lying around that I plugged into like the circuit that we just made. That's a speaker right there. And you can actually hear it pop a little bit. So the goal here will be to create some music. But how do we create music? The goal here is no other than just to blink an LED very fast at a certain low frequency, which is going to be around 100 to 200 Hertz depending on the note. What we'll also have to do to create music is switch between multiple notes. To do that, we'll use state machine, which is a very important concept to do what we call protocols later on. So once again, I made a Verilog module that outputs some frequencies and some notes played one after another. And so this project is kind of nice because you have to really understand state machine and how to generate different frequencies in Verilog. And once this is done, I just use it in the block design. And I also took the opportunity to make a small test bench. The test bench is just a way to instantiate our module and just check out if everything's okay, you know, in simulation. This allows us to check if our logic, well, just works before putting it on FPGA. And this is very important as a beginner to start and try to understand test benches, because debugging on FPGA is near impossible. And I use the Vivado simulator, even though I think it is very, very bad. It is bullshit. It doesn't work well. It is slow. I really suggest you move to other ways to test your designs once you get some experience. Okay, so let me flash the board. Bro, what the fuck is this? Bro.
Oh my god, bro. Oh, hell no, man.
Okay, let me put this out because it's fucking... But the idea was to generate, like, you know, arbitrary frequencies. This was a great beginner's project. It teaches you about state machines and stuff like that. If you don't have a speaker at home, you can just do a Simon Says game. If you have LEDs, it's just going to be a little harder. And overall, I think this project is pretty useful, but I'd recommend not losing too much time on it. So it is time for another project. Here we have the FPGA, and we have some traces going all the way here. These traces are linked to this chip, which is an FTDI chip, which translates UART signals into USB signal here. This is going to be understood by my computer. I can just open a UART terminal on this, but the goal here will be to generate UART signals here to send text to my computer. So there are two things to take into account. First, we have to, well, design the module to generate the signals, but also respect the UART protocol. Hardware-wise, we are going to reuse this concept of state machine to go through each of the steps of the protocol. Protocol is pretty simple, and all we have to do is send some adequate data to send the text we want. And of course, we are going to send hello world and send each character byte by byte. As usual, once this is done, we integrate this into our system using the block design because it's once again way faster. We can use some simulation and test bench to actually see if it works before implementing it on FPGA. Let's go, we got an hello world. Yay. So yeah, it's a pretty simple protocol, but it's a very great first step into implementing protocols. And once you've done this, you can pretty much do everything. So next we are going to make a VGA controller. What you have here is a Basis 3 board, and apart from the fact that it has pretty good aesthetics, it also has a VGA port on the board, which is pretty neat. So you don't have to buy a Basis 3 board, it's pretty expensive, I'm not gonna lie. You can also just buy an external VGA port on a PMOD carrier. And VGA controllers is a project that is often recommended to beginners because it's a project that feels way more real, quote unquote, and it also allows you to be pretty creative. So today I'm not going to be creative and we're going to make a simple PONG game. That is going to be our objective today. So I never made a VGA controller before. I stumbled upon a very great French tutorial. I'm gonna give you a link in the description, you can translate it easily. And it turns out that VGA is a pretty simple protocol. So I designed a first module that generates from a clock the X and Y coordinates as well as the synchronization signals. Because yeah, VGA is very simple, it's only 3 wires for RGB and 2 wires for the synchronization over horizontal and vertical axis. And of course I tested this first module using the Vivado simulator. I designed a second module because you also need, as I said, the RGB signals. So this module grabs in the X and Y coordinates, and depending on these coordinates it generates different colors. This is pretty much all you need to find yourself with a pretty basic yet rewarding drawing on your TV. Because yes, that is my TV on my desk. Don't be fooled by the wide angle of the camera because this TV is pretty fucking big. But okay, remember our goal is to have a nice PONG game. And the goal now is to use our HDL skills to actually create a game state. Game state. You can also use some button inputs to actually, gather user input. So my first goal here was just to have a state of the actual pad, on which the ball actually bounces off. So we very obviously do not have any pad. So I faced some basic bugs that were easy to fix. This one was because the button press was registered on every clock rising edge, which happens 25 million times per second. So it's a pretty easy fix. You just design a rising edge detector and then it works like a charm. Pretty slow. Let's try to speed this movement up. Oh, let's go, look at that. And then it's just a matter of messing around with the ball logic. But given the previous projects, you have all the knowledge to design such basic physics. Collision number 2, still good. I should stop at about here. Okay, it's working actually. I did not expect that. It's kind of slow, maybe we can do something faster. Ball BX, selecting the value 3 and ball UI 2. So let's program it. Okay, this is way faster already. Alright, it's way better right now. I'm going to end this project right here. We've got a pretty solid PONG game. It's not Call of Duty, but still it's a perfectly working game running on pure hardware. This project is overall great. It really gathers up all the skills that you learned before, and it also adds some other knowledge on top of it to actually make everything work. It's also definitely a very rewarding project. It's an actual resume-worthy project that you can actually use to actually show your skills. And yeah, it's a project I overall really recommend. Hey, I hope you enjoyed this video. Don't forget to like and subscribe. It really helps the channel more than you think. If you have a question about the GitHub code or the video itself, don't hesitate to leave a comment down below. I'll read them all. Love you guys, and I'll see you in the next one.